So hi guys, welcome to my video. In this video we will study about forward bias and reverse bias. In the last video we have studied about PN junction diode. So what was that? We can revise it now so that we have all concepts clear about that. So here there are p-type and n-type substances. Suppose that this is p-type substance, this is n-type substance, are in contact with each other. There will be a junction or a barrier which will oppose them. Okay, so their majority charges are holes, and here majority charges are electrons. So the electrons of this area will jump into the p-type substances so that it will fill that hole. So the depletion layer is formed, where we can make here as, we should make it as a big. So here there the depletion layer is formed, like we can see that. Okay, so here's holes, here are holes, and here are charges, negative charges. So it is p-type substance, n-type substance, and it is depletion layer. So this depletion layer has a positive side and a negative side. The electrons of this side cannot move here, and the holes of this side cannot move to the positive charge. So they repel each other as in the formation of potential barrier. We have studied yesterday potential barrier. Okay, so it will form potential barrier. So what the potential barrier do? Potential barrier oppose the charges, like this electron cannot move to that hole because there is a depletion layer between them. So it will not pass them, it will not allow to pass them. Okay, so we have revised what we have studied yesterday. So now we will start what is forward bias and reverse bias. So first of all, bias. What is bias or biasing means? Biasing, we can say it is a process. Which process? It is a process of connecting a PN junction diode with us in a circuit. What? Connecting a PN junction diode in a circuit. So there are two types of biasing: forward biasing and reverse biasing. So if we will understand there are two concepts of forward bias and reverse bias. First of all, I have told you that in the last video that semiconductor can allow to pass only in a one direction. It means electric current can pass through only one direction, not in the other direction. Okay, so it cannot pass to other direction. It will pass into this one, but this not. Okay, it will not, current will not pass through this direction, it will pass only through this direction. So we can say that is a unidirectional or single directional. So let's get started to forward bias. So let's talk about forward bias. So what is forward bias? Let's take an example of silicon wafer. Here is a PN junction of silicon. So let's connect to it with a battery. The p-type semiconductor will connect with the positive terminal of the battery, and n-type semiconductor will connect to the negative terminal of the battery. So now we can see that we have know that there are majority charges holes in the p-type semiconductor, like we see, and n-type semiconductor majority charges are electrons. So the positive charge and this positive charge will repel each other, and this negative charge and this negative charge repels each other. So before we do it, now we have a depletion layer. So here is a negative charge and here is a positive charge in the depletion layer. So after that, the repulsion occurs in the holes and electrons with these charges. So the depletion layer will decrease. depletion layer will depletion layer will decrease. Depletion layer. So here depletion layer decreases. So let's make a diagram of it. Let's take a simple N junction. So here our depletion layer decreases. Okay, so after depletion layer decreases, here is the diagram. The depletion layer decreases. Now we know that every electron has its kinetic energy. As it is a free electron, there are free electron in n-type semiconductor. First of all, there are charges. Okay, so now there are free electrons in n-type semiconductor which wants to move in a p-type semiconductor to fill the hole. So the kinetic energy stored in them will make them to move from here to here. Okay, in this case we have taken we know that the silicon has a potential barrier we have studied in the previous topic. So silicon has a potential barrier of 0.7 volt, has a silicon wafer, and we take external battery has a potential difference of less than 0.7. okay, so there is a less than 0.7 potential difference in the external battery. So the electrons will start to move as they have a kinetic energy, because battery provide EMF. We know that electromotive force to the electrons that will break the depletion layer. So now the depletion layer will break. And there will be a simple we can say that here is a p-type semiconductor, here is a n-type semiconductor. There are holes, there are electrons. Okay, so this is that. So let's connect to its battery. P-type with positive terminal, n-type with negative terminal. So now depletion layer is removed from that, and the electrons will pass freely from n-type semiconductor to p-type semiconductor, and the charge will flow. So before going there, let's come in this figure where depletion layer is here. So depletion layer is not removed here. So the flow of current will be in this structure. We can see that the flow of current charges will be from here to here. Electrons will move to the hole. Okay, so the electrons move from positive to negative, from p-type semiconductor to n-type semiconductor, from here to here. Okay, and we know that conventional current move upward. Okay, so that's all about forward bias. So before going to reverse bias, we can make a graph of forward bias. So let's take an example. There is a if it is potential difference of external battery is less than 0.7, it will remain unchanged. When the potential difference will potential difference mean that less than 0.7, so it can be 0.1, 0.2, or something else. So it will start increasing. When it start increasing at a point, it reaches as 0.7. when it's equal to 0.7, so it will moves here. This is a knee point. Okay, so from this point it will going upward directly. Okay, so it will increase continuously, so it will be greater than 0.7. So this was a forward bias, and let's talk about reverse bias. Now what is reverse bias? So let's make a PN junction here. So here are holes, here are electrons, here is a positive charge, here is a negative charge. This is P semiconductor, this is N type semiconductor, this is junction. So now connect a battery with opposite direction, like P type semiconductor will be connected to negative terminal of the battery, and N type semiconductor will be connected to the positive terminal of the battery. So this is a diagram. So now what will happen if this opposite charges are done? So you may know that if there is a reverse bias, so there will be no movement of charges. So that's a wrong theory. No movement of charges. I will discuss it after this. So this is negative terminal, this is positive terminal. This let's take this semiconductor, PN junction. So this negative plate will repel it, and this will attract. This is the negative terminal, this is the positive terminal, and this positive terminal will attract these electrons. This positive plate will attract these electrons of N-type semiconductor, and these electrons are also attracted by this positive terminal. So the electron will be centered in this way, and in this case in the p-type semiconductor, the holes will be attracted by negative charge, and holes will also be attracted by this negative side of the depletion layer. So this was the reverse bias. So I have said you that there is no movement of charge. This is a wrong theory. Here electricity is generated, but it is in negligible quantities. We can say that it is a negligible quantities. Okay, negligible quantities. So it is in negligible quantities. Why there is a flow of current in this PN junction? There is a reverse bias. So we know that there are also minority charges here. Their holes are we know that holes are majority charges, or we can say that holes are more than the free electrons. So there will be some free electrons here in a p-type semiconductor which have a kinetic energy, which will move from p-type to n-type semiconductor, but they have not enough kinetic energy to disperse or to pass from this depletion layer. But if they have, so they will pass from there. If we make a external battery having a potential difference between 50 to 70 volts, which is so much high, 50 to 70 volts is so much high. So if we take this voltage or this potential difference, so some charges will move from p-type semiconductor to n-type semiconductor, as there are minority charges which are as a free electron which will move from p-type semiconductor to this positive plates. We can see that here. So it will attracted by this positive plate, so it will destroy the depletion layer. But I have discussed that this charges flow from here to here will be in a negligible quantities, very low charges or very low electricity will not pass from here. So that's what all. So now we will have a conclusion. So there was a PN junction positive where the p-type semiconductor is connected with the n-type semiconductor, and have a junction because they are in a contact with each other. Junction work as a barrier or a bridge between them, which causes a n-type semiconductor electrons to jump into adjacent hole of p-type semiconductor, and this create a p-n junction diode. Now in the reverse, biasing means to connect the p-n junction with a battery. So in a forward bias, we see that the p-type semiconductor was connected to the positive terminal of the battery, and n-type semiconductor was connected to the negative terminal of the battery. So in the reverse bias, it was opposite to the forward bias. The n-type semiconductor was connected to the positive terminal of the battery, and p-type semiconductor was connected to the negative terminal of the battery. So we see that reverse bias did not pass electricity, but it passed sometime electricity because of minority charges in a negligible quantities, and forward bias passes electricity only in a one direction. We have seen there is single direction, so we can say that diode or a p-n junction is used in a circuits to give a single direction to convert AC current to DC.
So that's all for today. Bye.